It's kind of like a magic trick, a piece of industrial alchemy, really. We're going to see how engineers take the absolute gunk from the bottom of an oil barrel, the thickest, stickiest stuff you can imagine, and turn it into this surprisingly valuable commodity that's used all over the world. So, let's dive right in.
Right. We all know that oil refineries pump out the stuff that runs our world, like gasoline, diesel, jet fuel. But have you ever stopped to think, what about the rest of it? What happens to the gunk at the very bottom of the barrel? The stuff that's just too thick and heavy for anything else.
Well, that stuff has a fancy name, vacuum residuum. But let's be honest, it's exactly what it sounds like. It is incredibly heavy, super thick, and viscous. For the longest time, its main purpose was pretty unglamorous. It was used to make the asphalt for our roads. Okay, so here we are at the bottom of the barrel. And it turns out this heavy residue poses a massive challenge for any modern refinery. See, back in the day, refineries had a pretty easy out. They could just burn this heavy residue as a cheap fuel for their own operations or other industries. But now, with today's really strict environmental regulations, that's just not an option anymore. So suddenly, the industry had this huge problem on its hands. What on earth do you do with all this leftover gunk? And this is where the story gets really cool. Instead of just trying to get rid of it as waste, some very clever engineers developed an ingenious process to unlock its hidden value, a process called coking. So, what exactly is coking? Well, the easiest way to think about it is like a giant industrial-strength pressure cooker. It's a process called severe thermal cracking, where you use just intense heat to literally shatter those long, heavy hydrocarbon molecules into smaller, more useful pieces.
And the process itself? It's actually brilliantly simple when you break it down. You start with one input, that heavy vacuum residuum. You hit it with intense heat and low pressure, and you get multiple outputs. You get lighter, much more valuable fuels like gasoline and diesel, you get useful gases, and you get this, solid carbon-rich material. And we're going to talk a lot more about that in just a second.
And when I say intense heat, I am not kidding. We're talking about temperatures inside these coking units that can hit 520 degrees Celsius. It's that incredible heat that's the secret sauce, really. It's what drives this whole powerful transformation from a waste product into a whole slate of valuable products.
Okay, so remember that solid stuff I mentioned? The stuff left over from the coking process? Well, it turns out it's not waste at all. In fact, it's kind of the whole point. It's this unexpected treasure. It's called petroleum coke, or pet coke for short.
But, it's not quite ready for its big debut just yet. The raw stuff that comes out is called green coke, and it still has some impurities and volatile materials in it. So it has to go through another round of heating, a process called calcining. This purifies it, makes it stable, and turns it into this incredibly useful industrial material called calcined coke.
Now, get this. It turns out not all pet coke is the same. It's almost like it comes in different flavors, and each one has its own special job. You've got the most common kind, sponge coke. And yeah, it pretty much looks like a sponge. After it's calcined, it's used to make anodes for aluminum production. Then there's shot coke, which are these little carbon pellets, basically a cheap and easy fuel. And there's also fuel-grade coke, which has a bit more sulfur and metals, but it's perfect for really high-heat industries like cement kilns. But the real star of the show, that's a whole other level.
And that brings us to needle coke. Look at that, it has this really unique, crystalline, needle-like structure. This makes it the purest and by far the most expensive type of pet coke. Why? Because it is the essential raw material for creating the high-quality graphite electrodes that are absolutely critical for making steel and electric arc furnaces. Just think about that for a second. From the absolute gunk at the bottom of an oil barrel to a critical high-tech component. It's amazing.
So you see how this stuff that started out as a major headache for refineries is now literally fueling huge global industries. Let's look at just how big its impact is. I mean, its impact is just massive. It's used as a super high-energy fuel in cement plants and power stations all over the world. It is a critical, non-negotiable ingredient for producing the world's aluminum and steel. And it's the starting point for all sorts of advanced carbon materials and synthetic graphite. So the next time you grab a soda can or look at a steel beam in a skyscraper, there's a pretty good chance that pet coke played a part in making it. It's everywhere. This whole story really is just incredible proof of human ingenuity, of engineering creativity. It just goes to show you that with the right thinking and the right technology,
Even the heaviest, messiest, most difficult part of crude oil can be transformed into a strategic product that literally helps power modern civilization.
And all of this kind of leaves us with one final big question to think about. This amazing story of turning residue into a vital resource, it really makes you wonder, doesn't it? What other things out there, things we currently call waste, are just sitting around waiting for some clever process to come along and unlock their hidden value? Makes you wonder, right?